Now let us learn about the topic SAP HANA Monitoring and Troubleshooting. In this section, we will learn about how SAP HANA database will be monitored, what are the tools available for monitoring SAP HANA, and what are the parameters, that is, what are the valuable parameters that must be monitored, and from troubleshooting point of view, what are the settings that we can enable and what are the tools that we can use to troubleshoot the day-to-day issues. So mainly in this section, we will have detailed view of the functionality of SAP HANA Studio from monitoring point of view and check important files, that is basically by enabling different traces, how we can collect different data for monitoring and problem analysis, and how we can access these files, download them, submit them to SAP support in case if it is required, how to enable remote support, that is how SAP HANA is integrated in SAP Solution Manager, how to set up early watch alert for SAP HANA, work with diagnosis files, open the diagnosis files for analysis, as I said, by enabling tracing, and how to deactivate these traces, and also how we can analyze SQL execution by making use of plan explanation, plan cache, plan visualizer configurations that we have. Now let's move on. Firstly, let's start with how tracing configuration can be done and what are the possibilities of these traces and how to check these trace files. See, there are various traces available for obtaining detailed information about the actions of the database system. Basically, to analyze various issues, performance, and also to help SAP support, analyze, and diagnose problems with the system, we can collect diagnosis information into a zip file, then download it and attach to a support message to get the proper support. So there are various traces that can be activated and the thresholds can be configured in the trace configuration tab available in the SAP HANA Studio. So once we add the system in the SAP HANA Studio, we can open the administration editor, and inside that we can see the trace configuration tab, and different configurations options can be made available for each trace type. And for using this trace configuration tab, that is for making any configuration changes to the trace setting, we have to have a suitable role, that is trace admin. And to configure the kernel profiler, we should have SAP internal HANA support as the standard role. These two roles are available as a standard role in the system. So the user which will be used for making any configurations for traces should have trace admin, and similarly for configuring the kernel profiler, the user must have SAP internal HANA support role. And as I said, there are various traces. So technically, these are the type of traces available in SAP HANA database. So once we navigate to trace configuration tab in the administrator editor, we can see database trace, SQL trace, expensive statements trace, performance trace, and kernel profiler. By default, only the database trace is activated with the trace level error, and all other traces are inactive by default. And only in case we need a particular analysis, we enable, that is, we activate this particular trace and then make use of it and deactivate it once we are done with it. Okay, coming to database trace. Database trace, which includes user specific and end-to-end database trace, which is enabled by default, and this trace records information about activities in the components of the SAP HANA database. So it monitors, or in other words, it tracks each component of the SAP HANA database and tracks information about the activity each component executes. And this information can be used to analyze performance and to diagnose and debug errors. And each service of the SAP HANA database writes to its own trace file. Like for example, index server writes to its own trace file which starts with index server, and similarly name server. And likewise, all other components will write to its own trace files, which is easy to identify. And by default, we know that it is activated with trace level error, but this can be changed to warning also. And coming to SQL trace. SQL trace collects information about all executed SQL statements and saves it in the form of an executable Python trace. So basically, whatever SQLs are executed within the database using the SQL console or the HTTP SQL command line tool, the information about these SQL executions will be collected in a Python program for any analysis needed in the future. And next is about expensive statement trace. These expensive statement trace are individual SQL queries whose execution time was above a configured threshold. Expensive statement trace are basically used to track a long executing SQL query. That is, if a particular SQL query is running for a long time and you see that this could be a potential bottleneck for the system, then it makes sense to enable expensive statements trace to analyze this SQL query so that some problem analysis can be done and a suitable measure can be taken to fine tune this particular SQL query. So whenever we see that there's a huge load from SQL execution, it makes sense to enable SQL trace along with expensive statements trace and collect suitable information for analysis. And now coming to performance trace. Performance trace is built into SAP HANA database. That is basically performance trace records performance indicators for individual query processing steps in the database kernel. So it is inactive by default. For enabling this, we have to navigate to trace configuration here, which is shown, and click on the edit button and enable it. Likewise, for other types of trace too, like for database trace, it is enabled by default, whereas SQL is inactive by default, so we have to go to edit mode and then enable it. Similarly, for expensive statements and user specific end-to-end traces. Coming to user specific, any user specific analysis which has to be done. If we notice that the HANA database goes down when a particular user logs into the system, or if a particular user complains that the HANA database runs very slow for him, then we can enable user specific trace for that particular user. And end-to-end trace again will record end-to-end trace for the database. And we can also record end-to-end trace for a particular service too, that is particular component. So coming to performance trace again, information collected by the performance trace would mainly include processing time required to execute a particular step the data size read and the data size written to the disk, network communication, information specific to the operator or processing of a particular specific step. So with all this information, it is possible to analyze the performance of the SAP HANA database as a whole. And performance trace is stored with a .tpt format, and it is not possible for analyzing this performance trace by anyone using the Studio, but it needs a special evaluating tool which is used by SAP support normally for evaluating the performance traces for performance fix. And coming to performance trace options, we have several options available. We have to go to edit mode here, and here we can start the tracing. As I said, TPT is the extension for the trace file, and yeah, we can track all the database users, all the application users. You can also specify the application name if you are tracking a particular application, and yeah, use the trace level as medium or high, and also trace execution plans, that is SQL execution plans, and activate function profiler. So basically we can set for user and application here, and set the trace level and the execution plans, and then finish to enable this. And coming to SQL trace, which normally records information about overall execution time of each statement, number of records affected, and potential errors that were reported while executing SQL statements, and how database connection was used during the SQL execution. So basically and technically, SQL trace is a good starting point for understanding executed statements in the HANA database, and also analyzing their potential effect on the overall application and system performance. And SQL trace information is stored in the format of an executable Python program, as I said, which can be seen in the diagnosis file. So all trace files can be seen in this diagnosis files tab. And coming to tracing options, we have various trace levels. Let us navigate inside that. Yeah, once we activate it, we can choose different trace levels like all or all with results, error rollback for different functionalities, where all statements can be included with the all selection there, and all statements with errors can be included with error option here, and all statements that were rolled back are traced using the error rollback option, and all with results, again in addition to the trace generated with the trace level all, the result, that is all with results, returns by select statements is also included in the trace file. So we can choose different options here, and again, as I said, trace file ends with .py format. You can set the database user, application user again, and set the table or view, set the application again, and select the statement type. Use different checkboxes here to choose what statement type should be tracked, and then we are good to finish it. And thus the SQL trace is enabled. Any SQL statements executed thereafter will be tracked, and we can find the information in the diagnosis files. And coming to expensive statements trace, here are the options. So once I activate, I can, as I said, expensive statements will record the long running SQL statements which cross a particular threshold, and that threshold value in microseconds can be set here. And again, it can be set for user application specific tables and application, and we can choose the appropriate passport trace level. So that's how we can enable the expensive statements trace. And coming to database trace, which is enabled by default, as I said, see, it's available for all the components, and we can decide upon see by default it has taken the trace level on its own. Error situations are always recorded, and the format of the file will be always .trc, which can be found in diagnosis files tab. And if a trace component is available in all services, it can be configured globally for all of them. And we can also configure the trace level of a component individually for a particular service as shown here. You can configure it for different services specifically. And anything which is set at a service level can override the trace configuration at the all services level. So what it means is here under all services we can set a global trace level, and coming to particular components we can set the service level there also. So anything set at the component level can overwrite what is set at the all services level. And there are different trace levels available, like none, which is at the 0 level, then fatal, then error, warning, info, debug. And we should note that even if none is selected, information about error situations are still recorded. And coming to user specific trace, we can enable a specific tracing setting for a particular user for end-to-end analysis. That is, even though all services configuration is set to a different tracing level, for a particular user, we can set a different tracing level and use the tracing level for analysis. Like for example, for all the services for memory component, error is the tracing level set. We can specifically set warning as the tracing level for a particular user, say user A, and all the services would record based upon the tracing level warning for this particular user, user A. Whereas for all other users except user A, tracing level error applies. And coming to end-to-end traces, this is basically triggered by applications outside the SAP HANA database. So whatever default trace levels for the HANA database components are set, these are normally sufficient and no need to be changed at all. So basically the data about this will be collected based upon the setting what is done in SAP Solution Manager. Now coming to kernel profiler, which is the last one to be explained in the tracing option, which is right at the bottom. This also is inactive by default. Kernel profiler is regarded as a sampling profiler built into SAP HANA database. So technically, this is used to analyze performance issues with systems on which third-party software cannot be installed at all, or on the parts of the database that are not accessible by the performance trace. We know that performance tracing is done to analyze the performance of the system, and kernel profiler also stands on the same line. But kernel profiler can get into parts of the database to which performance trace cannot access. So it is like advanced performance analysis. And to be able to use, we know that as mentioned, SAP internal HANA support role must be assigned to the user. And this role is only for SAP HANA development support and should not be used for any other purpose. So basically, this kernel profile collects information about frequent execution paths or expensive execution paths during query processing. So this has to be started before the execution of statements if we want to analyze that particular statement, and should be stopped immediately. And we should not unnecessarily record any sort of statements which are not to be analyzed, because this can actually consume the resource on the HANA database server to some extent. So uh, mm, internally it can cause performance impact if run for a long time. And coming to configuration options, what we have, it is inactive by nature. We can start the tracing directly. See, we can trace different components, select them, and mention the wait time and mention the memory limit too. This memory limit will stop the tracing. So if kernel profiler starts to use a lot of memory, this limit can help to stop the tracing so that HANA database will not run out of memory. And wait time will specify the amount of time the kernel profiler should wait between call stack retrievals. And yeah, this also can be used for database user and application user that wants the profile to be used. And we can finish and then proceed to use this trace. And once the activity is completed, we can stop the kernel profiler tracing using this option. So that was about using different tracing options in SAP HANA Studio configuration tab for trace. So this picture shows how the activation of SQL trace and performance traces are done. Since we have studied this already in SAP HANA Studio, I would proceed further. So now coming to trace analysis. Once we have enabled the trace setting for a particular type, say SQL or performance, and then we have generated the trace. Now we should be in a position to use these traces for analysis, for problem analysis, and to provide a suitable fix. So as I said, all the traces are collected under the diagnosis files tab in the SAP HANA Studio. And as a prerequisite, privileged trace admin must be assigned to the user who does the tracing and who wants to do the analysis of the traces generated. And we know that when the database is offline, HANA Studio connects to the database in the diagnosis mode, that is without SQL connection. And during when the database is offline as well, we can make use of the diagnosis files for problem analysis to identify why the database has gone down. So with either connected or not connected state of the database, we can make use of diagnosis mode for problem analysis. So when the database is connected, the diagnosis information is collected through the execution of SQL procedures. So basically, this is done by database user, which is connected using SQL privileges, which does a select on the tables and views. And it is also possible to collect the diagnosis information without having to connect to the database. That is in non-connected stage, by making use of execution of Python script directly. And for this, we don't need to be logged in as database user, just the operating system administrator user is more than enough, that is SID ADM user. And again, to download, delete collected diagnosis information from the diagnosis files tab, we can either use the database user or the SID ADM user to download or delete or merge. Okay, so to display, and this is the Python script full system info dump.py, which can be used with or without SQL connection. So basically, when the database is not available, this is the Python script which can be used to get the diagnosis information. And to display the diagnosis files, we can navigate to diagnosis file tab in the HANA Studio, open the context menu of the list, and then just double click on the log file. And we also have options to download, delete the files from there. Now I've logged into the HANA Studio and navigated to diagnosis files tab. Here you can see that we have the option to choose Python script or SQL procedure. And list will list all the traces. And this is the list what we have got now. And you can see that traces for different components are generated. You can see TRC files. I'll come to what is GZ extension files, and you can see different logs, also development logs, STB daemon status log. You can also see backup log, available log. It speaks about backup, and available log will give information about availability of the database. And yeah, since no other tracing is enabled like performance trace for TPT files or SQL trace for PY files, we are not able to see them here. So let's try to open one of the files. For example, if I want to open this, I just right click and choose open. So I would get a detailed information of compile server trace, and I can analyze each execution of this component using this trace. So here I have options to choose the entire file or show only the start of the file, end of the file, and I can also choose the lines. And if automatic refresh wants to be used, I can choose the number of seconds I want. So likewise, I can analyze different traces and make an analysis to provide a fix. And additionally, we can filter by the service name. We can just enter index server and filter for the particular service alone and do the analysis. And we also have options to merge database related diagnosis files, where we can select multiple files to be merged. This feature is helpful during troubleshooting because it allows to select multiple diagnosis files to be used for reviewing for different types at the same time. And once the merged file is created from the most recent diagnosis files, this can be provided to SAP support for further analysis. And additionally, yeah, you see that you can select whether you want only trace level error, and you can export it to a CSV file and select the location. Also, you can choose the time range between which you want to select the multiple files. And also it is possible to delete a trace. You can just select this and then delete the trace. and delete any sort of trace like py, trc, tpt, and also .log files. And in case if the trace files are open, it is not possible to delete the trace files. In this case, what happens is only the contents of the files are cleared, but the file still exists. And we see that its size is reduced since we deleted the contents. Well, that was about how we do the trace configuration and how we analyze the traces that are generated using the diagnosis files tab. And this is the procedure how we call the Python script to navigate to this location. Under instance exe python support, use the Python and provide the Python script name. So these are the traces which are collected. And additionally, we can collect information from the system views by doing select on the system views for monitoring purpose. Now let's move on to understand more about analyzing SQL queries. So the SQL statements that are used with the HANA database can be analyzed for a more detailed analysis. And for this, we have different options like explain, plan, visualize plan, and SQL plan cache. And coming to visualize plan, which can be used through SQL console or SQL plan cache available in the performance tab, and also with performance and expensive tracing option. And here is the option how we choose explain plan or visualize plan for a particular SQL statement which is being executed in the SQL console. So once the SQL statement is written in the SQL console or after the execution, we have to right click on the SQL statement and then we are ready to choose explain plan or visualize plan. Now let's start with visualize plan procedure. Basically, to help understand and analyze the execution plan of an expensive statement or any SQL statement, we can generate a graphical view of its plan, that is, its execution plan. This graphical representation of the query will provide us an estimated performance of the plan, will give us an output with which we can estimate the performance of the statement that we are using. So for estimating this performance, we have to choose execute as an option, and another eye level graphic is generated with the execution time information for each of the parts. See, as shown here, once we visualize the plan and once we press F8, we get another tab here. The visualize plan screen will show us an information like this. It will break down the SQL statements into different portions, and when we execute it using F8 option, we get another tab by name duration, which will issue us the information about the time duration what it can take to execute. So by this we can analyze whether the SQL statement written is a fine-tuned SQL statement or not. If the value is very high, then it makes sense to tune the SQL statement and again retest by visualizing its plan. This graphic is a very powerful tool. SAP Solution Manager offers a central GUI transaction called Solman underscore Work Center, which offers a complete monitoring infrastructure where we can monitor the availability of the SAP HANA database better. And this central SAP GUI transaction can be used for configuration, setup of administration, and monitoring as a whole. So to use this Solman underscore Work Center for monitoring infrastructure, there are certain configuration steps which must be set up. And to set up this configuration steps, there are certain prerequisites must be met. So coming back to the infrastructure what we have in Solman 7.1, these are the options which can be used. We can enable remote DB monitoring, and at the same time we can use different options like log viewer, file system browser, interscope web view. We can use trace analysis, workload analysis, exception analysis, change analysis. There are wide variety of options available. So once the configuration is done, we can make use of all these options for different types of analysis. And this is the transaction Solman underscore work center, which must be used in the SAP Solman system. Or additionally, as another option, we can use an URL to trigger the Solman underscore work center. URL with extension SAP BC Webden Pro SAP AGS underscore work center is the URL with either HTTP or HTTPS. We have to give the host name and the port number of the Solman system correctly. This opens in a separate NetWeaver business client. Okay, and yes, for setting this up, there are certain prerequisites. As I told you, prerequisites will be like SAP Solution Manager 7.1 should have a particular support pack stack level. That is, it starts with basic level of SP02, but with SP02, we do not have DBA cockpit integration, and there is no SLT monitoring available. SLT, which is used for application. And the latest available is SP05, which is recommended to be used. So basically, requirements should be like have a basic version of SP03 at least. 2 is very old, so at least 03, or we can make use of the latest available SP05 or the latest, whichever is available in the service marketplace must be installed. And on the database server, we should have a diagnosis agent installed, which is of the latest version again. And host agent must have a minimum version of 720 SP84. There are certain SAP notes like SAP note number 1747662, which can sorry, it is 1747682, which can give detailed information about setup steps on how to enable remote monitoring for SAP HANA database, which explains detailed steps about host agent setup, SMT agent setup, and how to register SAP HANA to SLD, and how to enable the configuration step within SAP Solution Manager, and then how to use it. So to repeat, I would say have a solution manager setup of release 7.10 with latest support package, maybe SPS 05 or above, and install the diagnosis agent, which is of latest release on the HANA database server, and make sure SAP host agent on the HANA database server is 720 SP84 as a minimum level, but recommended to install a latest version available, and register the HANA database in the SLD available in the landscape, so that we get the SLD rec file after registering this. And this is the basic picture of the work center. We can see that we have different sorts of monitoring options available. Coming to system monitoring, which is very useful, you can see the alert inbox for day-to-day alerts analysis, and also navigating to system monitoring will give us a graphical chart of different components again, with different color codes to understand whether it is up and running or whether it is not running completely, few services are down, or whether it is completely down. So green, yellow, and red would indicate whether it is completely up or not completely up or completely down. Yeah, coming to understand how we set up the remote monitoring for SAP HANA database. This is the SAP node which I was talking about. We can make use of this SAP node to understand the complete setup procedure. Um, from the beginning, like how SAP solution manager should be set up, which support package stack to be used, and how SMD agent has to be installed, which version to be used, and also with respect to SAP host agent version, and how to register the SAP HANA database to SLD system for pushing the data to SAP solution manager. So coming to setup of monitoring, this is the work center. We have different steps available here. Once we open the transaction solver underscore work center, we have to click on the table tab, that is SAP solution manager configuration, and choose managed systems configuration here, and then choose the tab technical systems. There we have to drop down and then create a system, and this will take us through a guided procedure where we have to provide different inputs, and then we have to complete this procedure. So this would ask for information like HANA database SID, instance number, HANA database host name, product, software component versions, diagnostic agents, and so on. But alternatively, if SAP HANA database is already registered to SLD, that is System Landscape Directory of SAP Solution Manager, all this information will be automatically populated by the system. And then we are good to just select them and then proceed. In the screen shown below, you can see that the system is already shown. You can just verify whether all the details are correct and then proceed to complete the setup of integration. So make sure all the product instances and software component versions are right, and then you can click to complete the system creation in Work Center. And then next step is to configure the system. Once the system is created, we need to configure it for monitoring purpose. So for that, what we have to do is we have to again select the product under the same tab here. Select the product, and we have to do a prerequisite check there. Assign the diagnostic agent, enter certain system parameters, enter landscape parameters, and then choose to configure and create logical components, and then complete. So under technical systems, we will select the system. Once the system is created, we get the system list here. We have to select the particular row and choose the configure system. So once we click on that, this will take us through a guided procedure where, as I said, we do the prerequisite check and mention the required parameters and then complete the configuration. And once this is done, we can navigate to technical monitoring. In the work center, choose the technical monitoring tab and their system monitoring, and select the system and choose the start embedded or start new window option, whichever is necessary, and then click on availability to check the availability status of SAP HANA database. So once the system is created and then configured for monitoring, we can use this option, that is using technical monitoring tab, and then choosing system monitoring area. Under that, select the system and then check the availability of the system. So with this we can know the different color codes, whether different services are available or not. And also make sure that when setting up the system for setting up the configuration, it can fail with different color codes like yellow or red flag. Make sure these are corrected and then the setup is completed, so that we can avoid any sort of issues coming ahead in the future. Now, with this, we have understood how Work Center can be enabled for monitoring purpose. Now, coming to understanding about SAP remote support. What are the possible options available for getting remote support from SAP? We have understood that for remote connection to SAP Solution Manager, which is possible with SAP Solvent Release 7.1 SP02 onwards, we can set up standard SAP GUI and HTTP connection to Solvent for remote monitoring establishment. And for HANA database, we can enable a new connection type for any customer system in STFK by selecting the type SAP HANA database. So HANA database at the customer end can be monitored using a local studio placed at the SAP support. From local HANA studio, the connection to the customer network HANA system can be established via a SAP router, and then we are good to monitor the HANA database remotely. So basically, if you see this picture, we have different support connections to be enabled for remote monitoring. That is, we have R3 support, HTTP connect, and for HANA database alone, we can set up a connection from a local studio using SAP router, and then we can monitor the HANA database. And we can make use of command line tools also. And for making use of it, we need to enable SSH or telnet connection to the HANA database server and do the monitoring from the operating system level, or do any troubleshooting or problem fix. So for any ABAP based system, we can have these R3 support HTTP connections enabled, using which we can have R3 login and make use of DBA cockpit functionality. And for HANA, using the Studio tool, we can enable a connection using SAP router, and also at the operating system level using SSH or telnet connection. So basically, to enable this connection, we need an SAP router configured for the customer landscape, and then we are good to go. And in the STFK connection, we can choose the new connection type SAP HANA database. All that we have to do is to provide the port for SAP Start SRV and SAP HANA Master Index Server, and we can save the setting, and using that we are good to monitor the customer network HANA database from SAP support site. And for this, make sure there is an user with right roles like monitoring provided. Uh, um, a system user should not be used for such purposes. We need to create a specific user with role monitoring and also with role public, and this should be used for remote monitoring. And coming to command line analysis, there is a problem analysis tool called STB cons, which can be used um, against running processes. So executed against running processes using the communication channel setup. And using this, data can be fetched for HANA development support. And how we enable this setting? This is not available by default. A global setting must be enabled for using this STB cons tool. And also we can enable a management console for viewing the STB cons analysis. How this is done is using the HANA Studio. This is the option where we choose the setting for STB cons. We have to go to menu bar, choose window preferences, and under that choose SAP HANA global settings. And here we can select this management console for STB cons, and we are good to use the STB cons from the command line and then view the information collected on the management console. So with enabling this, we get another tab called STB cons here, which can be used. Now let us learn about SAP Solman early watch alerting. Here we can learn that monitoring of the SAP HANA database can be included into early watch alerting infrastructure, which is available in SAP Solman system, that is SAP Solution Manager. With all the supported scenarios, the monitoring of HANA database can be used for the SAP Business Suite applications. So this is the SAP node, which again will give information. To set up this connection, there are certain prerequisites which are to be met. Like firstly, we have to register SAP HANA database to SLD so that the information about HANA database is sent to SLD system. This can be done using the command line tool or using the lifecycle management option available in HANA Studio. And then install the SMD agent, the latest version of SMD agent for HANA database. And HANA database must be connected to SAP Solution Manager. The connectivity from the Solman to HANA database must exist. And service tool, that is STSER, with this version 701 2010 1 SP16 with the support package release, must be installed in Solman for using the early watch alert infrastructure. And then these two are the steps for configuring. We can run shell scripts on the HANA box, and this is the node which provides the shell script for running the we can download the scripts and run them on the HANA box. This is how we call the shell script. And we have to provide certain details about the HANA installation. And at the backend system, that is in the SAP Solman system, we have to configure the ABAP proxy for service oriented calls, which is done to the host agent running on the HANA box. So additionally, we have to make sure host agent running on the HANA box is of latest release. As I said, minimum is release 720, support package level 84. So anything above that must be installed. And we have to call the transaction server manager in the SAP backend and configure the service configuration. And then we are good to use the early watch alerting. But make sure we set up certain requirements like RFC destinations and configuring and activating ST, CCN, configure automatic activation of services, test the RFC destinations, assign logical component, and schedule the EWA download collection. So all this must be taken care of. But with the latest SAP Solution Manager release, that is 7.1 SP9, which is the latest, as I said, from SP05 we have a full-fledged functionality to monitor SAP HANA database. But with SP9 being the latest, a central early watch management procedure is available for setting this. So that is what is explained. And with this early watch alert, we can cover several areas of SAP HANA with respect to monitoring and data collection, that is system information, parameter configuration. We can uh, analyze size, growth, we can analyze performance, and we can check alerts and statistics. So with early watch report, we get different pages with different HANA checks included in the early watch report of an ABAP stack. And with this, with different traffic lights here, we can analyze all these areas of SAP HANA, where we can analyze the system information as a whole, parameter configurations done, and analyze volume growths, analyze tables and indexes, analyze performance measures of memory and CPU, and also analyze alerts and statistics for day-to-day monitoring. Now let's understand how to do performance monitoring using HANA Studio. With respect to checking on performance, what are the options available in HANA Studio? We have already learned how to enable tracing configuration for certain problem analysis and also for performance analysis by making use of performance trace, expensive statements trace. Now, what SAP HANA Studio offers as an option with respect to various other tabs which are available from administration point of view in the administration editor is what we will be learning now. Firstly, system monitor. System monitor option is available with a click on this button on the systems view. This will give an overview of all the SAP HANA systems at a glance, which are added in the systems view list. Say for example, I have added 5 systems to HANA Studio and I want to monitor all the 5 systems at a glance using the HANA Studio. By clicking on the system monitor icon, I can get a screen like this and see the status of all the systems in one glance, whether it is up and running or whether the connection is not working properly, whether any system is down, or whether it is in yellow state, that means any of the processes is not running. And at the same time, check for the generation of alerts, which priority alerts have been generated, how many, and the volume consumption and the memory consumption, CPU consumption. So at a glance, I can see the status, alerts, volume consumption, also with respect to performance, memory and CPU consumption. And in case if I see any major bottlenecks here, I can get into the system, just double click on it and I will be taken to that system so that I can use further options available in that particular administration editor for more analysis. So for checking this, the user logged in must have the monitoring role or the system privilege catalog read. And the object privilege select on schema sys statistics, so that select on various monitoring views present in sys statistics schema is possible. So a user with all these roles like monitoring catalog read and select on schema sys statistics can do performance analysis on any system. So coming to administration editor, which provides detailed information about resource usage, current alerts, system performance, system configuration, analyzing and troubleshooting issues. So with this, We are able to monitor overall system state, resource usage by system and host, check the status and resource usage of all the system components, that is index server, name server, statistic server, access engine, and check the auto failover status, configuration of hosts in distributed systems, and check for alerts issued for issues in the system, and also check for performance and resource consumption. Just check the disk space consumed, that is volume growth of data and log area, and also trace area, and check the overall system performance. So these are the basic or the overall options which can be made possible with the administration editor. And additionally, we know that we can set tracing options and download traces for supporting SAP support team. Next, let's move on to understand each tab of the administration editor. As you know that administration editor is available in the administration console perspective. As soon as we launch the studio, we can select the administration console, or other option is we can right click on the system, in the context menu choose administration editor, and we get a screen like this. The first tab here is the overview tab, which shows us the summary of overall status of the system. Summary in the sense it will show us the operational status, the start times, and whether it is distributed system or not, and version details, and volume consumption, memory consumption, and CPU consumption, and alert generation. So with this we get an overall idea as to how the system is performing. And this sign here shows the traffic color, or in other words the status color and the state of the system. Different states, like if it is of this shape with gray color, it means status is unknown, that is SQL connection is not working with the database, which must be checked. If it is green, that means all services are up and running, system is properly functional. If it is yellow, some of the services or at least one of the processes is not running, and SAP Start SRV may also not be reachable at times. So if one of the services is not running, or if SAP Start service is not reachable, we see yellow status here, which must be checked again. And if it is red, it means entire system is down, that is all the services are down and the system is not operational. This can happen when the system is being brought down, so immediately it will enter diagnosis mode. Now let's move on. That was about the overview tab. Now coming to landscape tab, it provides many subtabs like services, hosts, redistribution, system replication. This landscape tab is primarily used in case of a distributed system, wherein we have multiple hosts to be monitored. Then we come here, or if the status of all the services are to be checked, again we can use the subtab services, which lists all the services of the HANA database and shows its status, and also the detailed resource consumption. Okay, and next is, and the context menu on each service offers various functions. We will see what are those functions. And coming to hosts tab, an overview of all the hosts in a distributed system is shown. See, as seen here, you can see multiple hosts: host A, host B, host C, host C, and host T. And what are the functionalities of each host can be seen here, their main roles, and
the status of each can be seen here. So we can get a detailed information about the auto failover status and configuration of hosts. And also there are host reconfiguration options available here. And we can also remove a host from the system if you want to remove. We also have a level program to remove a host, but alternatively, we can use the HANA Studio landscape tab to do the same. And next is redistribution, which allows to execute redistribution operations. From redistribution, we mean uh, redistribution of contents owned by a host. For example, if we want to remove a host, we have to redistribute the data in it to other hosts and then remove it. And similarly, if when we are adding a new host to the system, we have to perform a redistribution there also. And other options like optimize current table distribution, optimize table partitioning. We know that we can do table distribution, table partitioning in SAP HANA. So this redistribution tab will give us options to optimize these table distribution and table partitioning. And last tab is about system replication, which allows us to enable monitor replication mechanism and do failover triggering. So in case of any system down situation, that is any host down situation, as a part of failover mechanism, we can do the takeover from system replication subtab. That is, we can see which is the primary host, which is the secondary host, and what are the replication modes they are working in, and what is the replication status, what are the ports they are operating in, what is the site they are located in, and in case if any of these hosts goes down, we can do a failover triggering to any other host. So as a whole, this supports the disaster failover mechanism. Now coming to alerts tab, it shows collected alerts for all the services, that is entire database by the statistics service for monitoring and problem analysis. So we can see alerts in this manner, also see the priority, and priority can be configured here using the configure tab, where we can configure the thresholds, set priorities, set email notification if you want to receive emails for certain priority of alerts. And all current unresolved alerts can be seen, and we can sort down the alerts based on the period to view them, and detailed information about individual alerts can be displayed here by double clicking on them. Next is about performance tab. Performance tab provides detailed information for performance analysis in subtabs. Okay, and it has subtabs like threads, sessions, blocker transactions, and SQL plan cache. So for complete performance analysis, all these four tabs can be used. Firstly, threads subtab will provide monitoring of all running threads in the system. And from here we can see what is the status of threads since when they are running, and see if there are any blocked threads which are indicated by warning icon. And the group and sort filter provides a meaningful and clear structure for thread analysis. So basically, as I told you, we can see a full details of thread execution. We can even kill thread, jump to calling operation. We'll see how to do that. Coming to session subtab, this monitors all the sessions in the current landscape. We can see all active inactive sessions, the related applications, blocked sessions, and we also get option to cancel sessions. And we can also see the transactions blocked by a blocking session. And additionally, we can see the statistics like average query runtime, number of DML DDL statements in a particular session. And Additionally, we can configure SQL performance expensive traces from here as well. So apart from the trace configuration tab where we can enable SQL performance and expensive traces, performance tab under session sub tab also offers to set SQL performance and expensive traces. Next is about blocked transactions, which helps us to analyze all blocked threads. You can sort by transaction ID to see the relationship between two views better. Okay, once we navigate from thread sub tab for transactionally blocked threads, we can navigate to blocked transactions to take a look at why this transaction is blocked. What is the reason behind it? The reason for a thread to be blocked could be that the running transaction for the thread is blocked for some reasons. So we need to analyze this and fix it. And lastly, we have SQL plan cache, which is already explained, which stores the compiled executed queries which can be reused. So the compilation time can be saved by doing this. And it also keeps statistics about each plan, each statement plan. For example, executions like it stores the average runtime, minimum, max, total runtime, lock, wait statistics. Next is about expensive statements. Expensive statements tab sub-tab shows individual SQL queries whose execution time was above a configured threshold. So based on the expensive statements trace setting that we have done based on a threshold, the data will be collected here for further analysis. So we can configure for each user or table view or application statements to get recorded. Okay, and collects SQLs based on statement memory tracking and statement memory limitation setting that we do when we enable the tracing. Coming to job progress, this monitors all the jobs running in the system. That is, monitors the progress of long running transactions, especially to check load creation. And also we can view connection that triggered the operation, start time of the operation, steps of the operation that I've already finished, and maximum number of steps in the operation. So gives a detailed understanding of the job that is running in the system, and do an analysis based on the current progress, max progress, and how long it is running. And finally, load subtab, which gives a graphical display of current performance. That is, it gives a graphical picture based on values like CPU usage, memory consumption, table unloads. Compare performance between hosts is also possible using the loads subtab. So we can generate graph based on these values and do an analysis. Though it looks little clumsy, but a detailed analysis which would take some time can give us good value for understanding the performance. Okay, that was about performance tab as a whole. Now coming to volumes tab. Volumes tab gives a direct picture of the disk consumption, that is disk usage. That is basically volume size of data area and log area and trace area. And yeah, it stores activity statistics, and the picture here, the view here is divided into service type and storage type, so that we can divide and then check the picture differently for analysis. Next is about system information tab. This lists several predefined SQL select statements on system views. These are compiled SQL statements which are saved for monitoring purposes for convenient repeated execution. If I want to do system monitoring using certain SQL statements, what I can do, I can create SQL statements and save them in system information tab and use them regularly. Or by default, HANA database comes with a set of SQL statements for monitoring purpose, like for checking the number of table unloads, amount of memory saved with table unload. All such statements can be pre-saved here and used regularly for monitoring. Next is about configuration tab. We know that we can configure SAP HANA database under INI files in different sections. We can view, modify these properties. And coming to diagnosis files, we know after tracing the each type of trace, that is setting trace configuration, we can generate logs and traces for problem analysis. No doubt logs are generated by default with the activities in the database, but for different tracing apart from database trace, we need to enable the tracing, and the appropriate traces get accumulated in diagnosis files tab for analysis. And trace configuration, as explained, is used to configure different tracing options for problem analysis. And that was about different tabs available in HANA Studio for problem analysis and performance measurement. Now, with the latest SPS 9 we have certain dashboards and memory overview and resource utilization screens available, which are based on certain special UIs called SAP UI 5. So firstly, it is SAP UI 5 based monitoring dashboard. For opening this dashboard, we need a role, SAP HANA admin roles monitoring for the user. Only then we can open the dashboard. So this basically shows information about current high, medium priority alerts and performance values like memory, CPU usage, and availability of data backups. See, this gives a dashboard picture like this where you can see the overall status and also check the information about number of hosts running, not running, check the priorities, check various historic values, check the disk usage, check the performance values, check the active sessions, running jobs, backups, number of dumps, crash dumps that we have, and whether system replication is available. So this gives, and also the general information, an overall picture like how we have it in overview tab. This gives a similar picture but much advanced with respect to backups, crash dumps, system replication, and other detailed information and historic data. So this gives a one-shot view where we can know how the system is performing as a whole. And next is about memory overview. Next to open dashboard option, we have memory overview. And how we open this is right click on the system. In the context menu, we can select these options. And coming to memory overview again, it provides a detailed graphical breakdown of following categories. That is basically memory usage. You can see physical memory, HANA used memory, memory used by tables, memory used by DBMS. So all this can be seen here. We can generate a chart like this and also see different values in the box below and make the analysis accordingly. We can see different sections using the memory and which is using more, whether row store or column store, and make an analysis and work on it accordingly. And lastly, we have the resource utilization option, which enables us to visualize and explore key system resources like CPU, memory, disk. Again, it analyzes CPU, memory, and disk for performance measurement. What we can do here is we can select what we want to view as a graphical plan or a graphical view. Just select the row, and this shows a chart like this. You can select the duration from when to when you want to check the growth of the particular memory or the variation of CPU consumption, and it gets selected here and you are good to see the value over time. So like this we can make an analysis. If you want to analyze the performance of a system for a week or for a day or for a month, we can make use of this option, check for different values, check how the variation goes, and just to estimate during which time zone we have major concerns with respect to performance and what we can do there. Yeah, let me show it in the HANA Studio about different tabs which I have explained. Well, you have already understood about overview tab. Let me get into landscape tab now. Well, as I told you, see, these are the different services available. See here, the SAP status RV connection is not working, that's why it shows yellow. Whereas all other services are up and running. And also you can see the CPU memory consumption, used memory, and navigate towards right to check more values about memory and the SQL ports assigned. And right click on the service and you can use to stop, kill, reconfigure if any dynamic parameter is configured, start any missing service, reset memory statistics if you want to reset. If you see that memory statistics are not showing correct values, you can reset them. Check the memory allocation statistics, which gives us a graphical view of memory, memory allocation statistics for that service. And coming to host, you can see different hosts configured, check their status, check their role configured as a distributed system. And under redistribution, as I told you, you can perform redistribution uh, before removing a host, after adding a host, and optimize table distribution or optimize table partitioning. And under system replication, as I told you, you can see which is the primary, which is the secondary, what is the replication mode, status running, and do a takeover. You can right click on the system and do a takeover. So that was about landscape. Coming to alerts, as I told you, you can check all the alerts or recent alerts. You can double click, chain them uh, with respect to configuration using configuration settings. You can change the thresholds. You can set periodic checks. You can enable email functionality, mention the email IDs here, the SMTP server configured. And coming to performance, as I told you, you can check different threads. You can right click on them, cancel operation. You can view more details. You can navigate to, as I told you, any thread IT. You can navigate to session, blocker transactions directly from you. You can configure trace directly from you. As I told you, SQL performance expensive statements trace are possible. And yeah, coming to sessions, you can view all the sessions running in the system. You can right click, you can navigate to threads, go back to threads ID, go to blocker transactions, configure threads again. You can cancel the session also. Coming to blocker transactions, there are no blocker transaction in this. So though you navigate to block a transaction here, it will not show you anything. There is nothing for that connection ID. SQL plan cache, if there are any SQL statements stored, yes, we have a lot of SQL statements cached already, which can be used. And yeah, you can visualize the plan, access tables again. And expensive statements. Let me just visualize a plan. Let me see, show you. Yeah, this is how it shows. You can, yeah, this is the visualized plan. Yeah, and this is the execution. You can take a look. When I pressed F8, it shows me the execution time in milliseconds. Okay, so that was about the visualized plan. Coming to expensive statement trace, there is no expensive statement trace setting done, so we don't see anything here. If it is said, if there are statements crossing the threshold, then we can see the values here. Coming to job progress, we can see the current running jobs. There are no jobs running. If there are any jobs, we can do an analysis using the job progress subtab. And coming to load subtab, as I told you, this gives a graphical picture about different values like CPU. See, we can make a selection here, CPU, memory allocation, disk allocation, and do an analysis. And next is coming to volumes. Performance subtab, performance tab in HANA Studio is very valuable with respect to performance analysis, and any performance analysis which has to be done, we can directly use this tab and do the analysis. Coming to volumes, again, as I told you, this gives service based and also storage based. So you can take a look at here, the service based, and you can select storage based here to see the entire storage. So you can see different statistics again to analysis, and service based, you can see which service is consuming more. See, you can display the statistics again here. Takes a while to load. Next is about configuration. Different INI files are here, different sections can be configured. Next is about system information. As I told you, there are a set of predefined SQL statements which are cached here. For monitoring, you can just execute them and see the output. See, I can take a look at the present connections present in the system, list of transactions that are working, and also see any record logs. So it offers various predefined statements which are very useful for analysis. Rather than we writing an SQL statement, we can directly make use of these for analysis. Next is diagnosis files. This I have already explained. We can see different traces here and about trace configuration. And additionally, right clicking on the system, we can also take a look at open memory overview and also about this takes a while to load since it has to fetch the information to be shown in the graphical view. And also check the resource utilization. Well, coming to memory overview, you can see that for the host that we are using, if there are multiple hosts, you can just click on, we will have different hosts configured here. Just click on them to see the values of each host. Yeah, you can check to see the values in different parameters like MB, bytes, KB, GB, TB, based on the size of the system, and see different values. Scroll down and see different values here. Coming to resource utilization again, as I told you, you can um, select any row to generate a graph for that. Yeah, this is, for example, if I calculate for a day's time, then you can check the usage and do an analysis. So you can compare between heap memory and CPU time consumption. And if there are multiple hosts, there is an option to compare between two hosts also. Different hosts will be shown here and you can just select them and do a comparison between how performance varies between different hosts in a distributed system, and then based on the analysis, right decisions can be taken to improve the performance. So with this, now we have understood how to do monitoring and how to do troubleshooting to an extent, and with monitoring, how we can do performance analysis for SAP HANA database. So this concludes the topic.